Hey, what is eBGP Peerings? Well, find out next right here on IT Pro TV.
You're watching IT Pro TV.
The topic that all of us as the CCNA level dread just a little bit, BGP, but we're here to find out more, and here to help us along is going to be Anthony Socara. Anthony, what are we talking about here?
Yeah, we are talking about something really confusing for a lot of students when they're first starting out with BGP. It's eBGP. In fact, what's the deal? I mean, isn't BGP just BGP? As it turns out, Ronnie, we distinguish between interior border gateway protocol and exterior border gateway protocol, peerings. And we have to do this because the protocol functions differently if you're peering within an autonomous system as opposed to peering between autonomous systems. So when we peer between autonomous systems, this is really what I consider like the classic use of BGP. To peer between your ASs, when we do it that way, it's eBGP technically that we're working with, and eBGP is going to have some distinct operational characteristics compared to iBGP.
All right, so when we start talking about this idea of that BGP and splitting it apart here, our focus is on eGP, and the reason for that is because what we've learned before is just being able to route inside of a single autonomous system, and this is going to be the protocol that we need to use if we're going to be routing between autonomous systems, right?
Yes, it works this way. Border Gateway Protocol, it was designed to route between autonomous systems. IGPs were designed to route within the AS. But what happens is we need to be able to carry Border Gateway Protocol specific information inside of an AS at times. So iBGP is a variation, if you will, of the BGP. It's a different operational characteristic. You know, Ronnie, I got to say, this makes a lot more sense if we look at it. Okay, so let's jump into a topology that I've set up in none other than Cisco's Viral product. And by the way, this could be in our practice labs here at IT Pro TV. You could be in GNS3 if that's your thing. Ronnie and I just grabbed Viral because we happen to own a copy. But let's go in here and take a look, Ronnie. So do you see the peerings that we would have inside this autonomous system of 65213? R1 is going to peer with R2 and R3, and it's within that autonomous system, Ronnie. So those are iBGP peerings.
All right.
There are special rules about those peerings compared to the peering that we might do right over here between R2 and R3, or R2 and R4, excuse me. This is where we would have an eBGP peering because it's between autonomous systems.
All right, now, Anthony, I know that there's a way that I can even go ahead and do routing without even using BGP if I do route redistribution. So why would I choose BGP?
Great question. So let's say that we're a small branch office and we just need to get to the internet. BGP is not the protocol that we need in that scenario. We just have a default static route pointing out to the internet. So we don't need to run BGP with our internet service provider. So if you don't need it, don't run it. And that's why we don't see BGP in small environments. It's not needed.
So in a larger environment, then, there's got to be situations in which we would actually choose to use BGP to do so. And that would be sort of like the diagram that we're seeing right now, right?
Yes, the diagram that we have right now is a classic one. Look at that. It is two connections out to two different ASs from this one big AS. You could consider that big AS up at the top, what I have labeled as 65213. Just imagine that's like a huge enterprise like Microsoft, and they have these connections to different autonomous systems through different providers. They're going to want to control how traffic flows into their AS and out of their AS, and BGP gives us the controls that can do that.
All right, so how are we going to be able to see what we need to do? So on our side of what we would normally do, we'd configure our end, but if we're dealing with the ISP, are we configuring their equipment too?
Yeah, that's this is such a great point, Ronnie. These are static configurations that must be done in both locations. Let me demonstrate. So here on R2, this is one of the routers that we control, Ronnie. We're going to go in there and we're going to say router BGP 65213. Now, let me just show you something. If I run a command, do show run section BGP, I'm going to see that we already have BGP set up here on our router, and you can see that we are peering with the R1 device from the R2 device, and you can see that we're using our loopback, so we have the update source loopback 0 in there. So that is our eBGP peering right there. What we're going to do is we're going to go into the BGP process and we're going to create an eBGP peering one side of it. The provider we're working with, they have to create the other side of it, Ronnie. So they need to make the correct configuration over on their gear. So I'm peering this time with 192.168. You need the neighbor command. That would help. Neighbor 192.168.0.4, and it's remote AS 65004. And then we need that update source because we are peering with the loopbacks. So I do update source loopback 0.
All right, so let me ask you the question here,
Sure.
okay? I have a physical IP address on the interface that's going out here. Why would I choose to use a loopback address
Great
instead
question.
of a physical one?
So we had like you said, there is an IP address on that physical interface. We don't use it to give more pathing options. Maybe we have a situation where there's actual multiple paths between us and the ISP's device. We can now fail over using those multiple paths because we're going to a virtual IP address on the router itself.
All right.
Now, Ronnie, I said there was differences between eBGP and eBGP, and let me prove that.
Okay.
We need another command here, or this peering is never going to come up. And it's the eBGP multi-hop command. You see, exterior border gateway protocol, eBGP expects a direct connection. We technically don't have one. We're peering between the loopbacks. They're not looked at as directly connected. They're looked at as 2 hops away. So I need to do the eBGP multi-hop command, and that is clearly unique to eBGP.
All right, so is 2 the only option that I can use?
Great question. If I go in, and you should always do this when you're practicing, you should always go in with context-sensitive help, even if you don't feel like you need it at the moment. The reason I say that is you should go in and explore what your options are. And you can see, Ronnie, we can configure from 1 to 255 here. So please, as you're practicing, do the context-sensitive help so you can see all the different options.
Why not pick 255?
Yeah, that's funny. That's a CCIE lab exam
Oh, is
trick.
it?
Yeah. Students will go into their CCIE lab exam and they'll configure this and they'll say like 255. And they're like, I'm just going to make sure it works. And that wouldn't be graded as incorrect by a proctor, but it would be looked at as sloppy.
Oh.
And like, oh, this person's just trying to jam in a config that works. So be careful about that. In a production network, we wouldn't set 255 because we don't want the traffic to go some crazy many hop path and still work. We want to constrain it to what's reality. And reality wouldn't be 230 hops away.
So are there like 6 or 7 more commands that we have to do to make this work?
No, that is it.
Oh, well, that's good.
And if I went too fast for any of our learners out there, good news. We're going to pretend we're at the ISP now and we're going to do the other side. So over at the ISP, they go in and they go router BGP 65004. I said it right and typed it wrong. Don't you love when you do that? And they're going to have to do this neighbor 192.168.0.2. And it's going to be remote AS 650.213, I believe. There we go. And they're going to have to do the update source, loopback 0. And they're going to have to do the remote eBGP multi-hop. There we
So
go.
the IP address that you're using there is the loopback address. It's not on the
It is the
physical.
loopback
Okay.
of the neighbor.
Just wanna make
And
sure.
look at that. That
Hey.
eBGP peering came right up. So there we go. We have the eBGP peering. Now, I don't trust this one message. Now, okay, let me be completely honest. In the CCIE lab exam, or even in your Encore certification exam, if they asked you to configure an eBGP peering and you see the message pop up on your screen that I've highlighted in blue there, then you're good. I wouldn't bother to do additional verifications. But in a production environment, it's most likely that we're going to want to verify more things about this connection. So the show IP BGP summary command is the star of the show when it comes to verifying this. Notice, Ronnie, that here on R4, I can see that I did peer with the correct device, and that is 192.168.02. I can see that it's version 4 of BGP. I can see the remote AS is 65213, that we're sending messages back and forth to each other successfully. The table version has to do with updates and convergence. We can ignore that for now. In queue and out queue, we're going to deal with, are we getting like overly congested with BGP updates? The up down time is, oh, look, we've almost been up for a full minute. And then this is the column I wanted to spend a few moments on. This can be confusing. Notice it's going to show you state if you're not in the full state. If you are in the full state, it's going to show you a number, and that number is prefix received. So we have peered with eBGP between R2 and R4 here, but we have received no prefixes from the R2 device.
Now, that sounds very similar to EIGRP when it talks about passive and active states. Are we talking about the same type of thing here?
Very, very similar. EIGRP and OSPF, when two devices are peering, they go through phases, Ronnie. So OSPF has like the X start state and the exchange state, right?
Right.
That's what we're talking about here for state. So EIGRP does a similar thing where this neighbor is configured for EIGRP and so is this one. They find each other and they go through phases. It's not as famous with EIGRP and it's not as broken down, but that's BGP definitely does that. It goes through an init phase and then, you know, this next phase, and the peering comes up in phases, and that's what you'll see there. But remember, we don't want to see a state reported there typically. We want to see either 0 or some number of prefixes received to indicate full state.
So if we have a 0, it means we are peered, but we haven't really received
Any
type of prefixes
Yes.
so far.
And let me break it. Let's break it.
Okay.
And I'm going to break it in a way that is, you know, actually demonstrates a best practice. We're going to do this, Ronnie. We're going to say neighbor 192.168.0.4, and I'm going to say password. And so we are going to set a password on this side of the equation. And what's actually being done, even though I enter it in clear text there, it is an MD5 hashing that's going to be done. So this is adding an MD5 security check to the process. And this is interesting. It doesn't break right away. So that's interesting. If I do a show IP BGP summary on the R2 device, it's got its iBGP peer of R1 and its eBGP peer of R4, and they're both happy. There is going to be a timer involved here with this relationship breaking because one is configured now with the password, one isn't. One of the things we can definitely do to cause an issue here is let's go ahead and just bounce this connection. Watch what I'm going to do. 65213. I'm going to say neighbor 192.168.0.4, and I'm going to say shutdown. So I'm going to force the neighbor to shut down, and then I am going to come in and say no shutdown. And actually, you can't do it that way. What you do is this. You go no neighbor blah, 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 shutdown. There we go. So we get rid of that neighbor shutdown command. And now what's going to happen is, look at that. We got a we got a no MD5 digest message there. So it's going to keep trying to bring up this relationship. It's going to fail. And now watch this, Ronnie. Here's what we see with show IP BGP. Look at that.
Idle.
It is idle. Yep. It's sitting there right now going, I don't know what to do. It will try again, and it'll move from like idle to connecting or whatever the name of the state is. I should probably have that memorized, but we could look it up, the various state names that it can cycle through. Not that important. What is hugely important is there is a configuration error right now, and that's why we're not seeing a number of prefixes received there. To fix this, let's see. To fix it is simple. We're going to go in and we're going to say router BGP 65004, and we're going to say neighbor 192.168.0.2, password Cisco. And this will be fun to see how quickly the peering comes up at this point. If I do my show IP BGP summary, we're still idle. And we know one way we could force it, we could kick it into gear. And in the CCIE lab, Ronnie, I would do this. Oh, it just came up. Before I could show you what I was going to do. But what do you think I was going to do? I was going to shut it down and then no shut it as a way to force things into convergence. Now let's try our show IP BGP summary again. And there is our fully established peering with our 0 prefixes received.
All right, and we have those 0 prefixes that we don't have any prefixes being advertised in here, and that's something we definitely need because of the way that BGP works. So it doesn't seem to be filling in that the routes that we need or anything else, right?
That's right. It's very static, very manual. That's the first kind of paradigm shift with BGP we have to get used to. We are statically defining peerings. We are statically advertising prefixes. Kind of. You'll see in the very next episode.
Yeah. Now, just one more question then, okay? If I'm having to statically do everything, why not just use static routes?
Well, the static routing thing is hugely popular for us on the interweb, but for those small offices, remember, Ronnie, again, for even IT Pro TV headquarters, I'm betting if I go to our edge router, there's a static route to get out to the internet. But remember, when we are talking larger enterprises and ISPs, they desperately need border gateway protocol. The ISPs themselves, as they are constructing the internet and they're moving prefixes, static just won't get it done.
All right, Anthony. Well, thank you again for helping us to understand the idea here of eBGP peerings. We still need to think about the idea of getting some prefixes to show up in those routing tables, but that is for another episode. So signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.